going to be going over metagenomic read mapping. So you can find it under the tools and services, like with all the other services. It's under metagenomics, and it'll be the one at the top right above taxon classification. So the metagenomic read mapping service uses KMA, as you can see here at the top. I also don't know if we went over this yet, but if you click this little stack of books right here, this will take you to a nice tutorial on how to use the service and provide a lot of references for what we use. This is all painstakingly put together by Rebecca, so you can thank her for this easy to use guide. So yeah, as I said, it uses KMA, and essentially this will take your reads, your metagenomic sample, and it will use a technique called k-mer seeding. So it takes a snippet of your reads, attempts to place it on all the sequences in your database, and then tries to extend that k-mer from that read until it gets a decent match in your set and in the database. We have two AMR databases available for this. One is our gene sets, one is CARD and one is VFDB. CARD is the Comprehensive Antibiotic Resistance Database, and VFDB is the Virulence Factor Database. So for the example that we're going to do, make sure it's selected to CARD. Well, actually first, let's go back to AMR Workshop. So to get to the data that we'll be using for this example, let's go back to BVBRC Workshop, AMR Workshop. You scroll on down to metagenomic read mapping, you'll see this content here. If you click on this file, SRA accession, this will give you the accession number that we're going to be using for this example. It may take a moment to come up because of the internet, so I'm also just going to type it in right here if you just want to follow along. It's ERR 7916262. And so we can go ahead and click that, and it will put that over here. If you saw very quickly, there was a message that said validating. And so essentially, if you put an SRR number into the text box here, when you click the arrow over icon, it will make sure that this is actually a valid SRA number and you're not just submitting a useless number that will ultimately fail your job. So just a little checking before we actually start things. All right, so we have that in there. We have this set to CARD. Let's choose our output folder again. And then we'll just call this their name. All right, so the submit button is blue. We are good to go. You can go ahead and click submit. And this, like the taxon classification job, will get put into the queue. And once there are enough resources, it'll actually be run. So while we wait on that, if we go back to the metagenomic read mapping folder, we can see some example outputs for that SRR number. Let's go to the most recent one here, which is this one, this demo job result. Again, the checkered flag tells you that this is a job result. So clicking into that, we can see there are a couple different outputs here, but the main one you're going to want to look at for metagenomic read mapping is this read mapping report. So if we click on that and click view, this will bring up the HTML report that will give you all of the results from your metagenomic samples hit to the selected database. So if we go down here, you can see we have a number of different results. Let's see, this is the database and hit that we got to. So this is I believe it's the same example as the one used in taxon classification. So as you can see, we have Streptococcus in here, which was shown in that Corona chart. We also, importantly though, have Haemophilus, which is the topic for this workshop. And this is resistance to beta-lactam antibiotics. So this is the one that we are currently interested in. And the hit was for this NP 439290. So what we're going to do with that, so we can take that over to GenBank, go to protein, put that in. And as you can see, we got a hit, but the record was removed. So we find the new entry for it, which is this new WP underscore lots of numbers. And so that brings us to what this protein actually is, this peptidoglycan synthetase FTSI. And so all of these different hits, you can go through that same process to discover what it is in either GenBank or in another database. These columns here, well, obviously genome is the genome that it hit in the database. And each of these columns is going to give you some metric that quantifies how well that read mapped to it, its depth, etc. And a p-value for the significance. So that is a broad overview of the read mapping service. Do we have any questions about this, the results, or the example?
I gather there's different specialty databases you can map the reads against if you're interested in
Yep.
antimicrobial resistance or virulence factors.
Yep. And so that is one of the other databases right here. Selecting that will give you a similar report, just with the results matched to that database instead of the one we used, CARD.
So that's virulence factor database.
Yeah.
Where does that go?
Beijing. That's the gold standard, BFBB.
So that's really it for metagenomic read mapping.
We got two questions from one person over here, and I just wanted to say it out loud so that other people are also aware. So going back to the read mapping surveys, one question was, instead of using the pre-configured CARD and BFDB databases, can you use your custom gene database to map read against only those set of genes? And the answer to that is yes. So you can create a feature group from the system. So I showed you how you can search for different set of genes using different methods. And as we go through the pathways and subsystems and other things, you'll see how you can use those annotations also to find the genes that you are interested in. But assuming that you have found a set of genes and then you have saved them as a group, you can select your feature group as a database and map read against only those set of genomes. So this is also relatively new functionality, but you can select the feature group, then you can select the group that you have just created. So in this case, let's say if I want to take Haemophilus influenza LPTE genes, it can be any set of genes that you are interested in, right? And then if you run the same process, then it's going to map read against only those genes and then give you whether those genes are identified in your metagenomic sample or not. So that was question number one. The question number two was, CARD is good for antimicrobial resistance, VFDB is good for virulence factor. Can we have a database here for identifying the genes that are resistant to heavy metal? And this is something that I don't think we have ever talked about it or paid much attention to it, but there is apparently a database that is well characterized for genes that are resistant to heavy metals. So BECMET, I think we should write it down. We can see how well characterized that database is, and if it's good enough and easy to install, then we can definitely make it available as an option here.